Okay, this is section 1.1. We are going to be discussing functions today. So to start off, I have a couple of definitions up here. First, a function. This is the relationship between two variables in which each input variable yields exactly one output variable. So there's exactly one output for each different input. The independent variable, these are the input values. They're the values whose value affects another variable's value. The dependent variable, those are the outputs. This is the one whose value depends on the other one. So usually our independent variable, we use the letter X for that, and the dependent, we'll usually use the letter Y for that. The domain are the different input values that you may use as an input. The range are the different output values that you get from those different inputs. Okay, we have four ways of representing a function. We can talk about a function verbally, numerically, graphically, or analytically. And I'm going to give you just one example here. Let's suppose that we took a cup of hot coffee. Let me do it this way. A cup of hot coffee. And we took the temperature. So we have a cup of coffee, and the temperature of the coffee is a function of the amount of time that has passed since it's been poured or brewed. So the temperature of the coffee is a function of the amount of time elapsed since brewed or poured. Let's say poured. Okay, so numerically, what that would represent is we could have time and a table, and then temp. And so say at time 0, so let's let time be in minutes, and this would be the number of minutes elapsed since poured. Let's say we measure it every 2 minutes for 12 minutes, and then the temperature starts off at 101 degrees Fahrenheit. Let me put that in the top. So 101, and then 2 minutes later, suppose we read the temperature and it's 99, and then 98, and 96, and then 92, and then 83, I don't know, and then 81. That's probably not anywhere near what it would be, but that's an example of a function numerically. Then graphically, a function, if we were to graph this, you would see something along the lines of this. And graphically, functions pass vertical line tests. This is something that you have learned before. Passes a vertical line test. That means that over the graph, you can put any vertical line, and it only intersects the graph at one point. That was a terrible looking arrow up there. Okay, and then analytically, a function looks like something like y equals, I don't know, 1 over x, for example. A lot of times we will say f of x equals 1 over x, where f is temp of coffee, temperature of coffee. And so the letter y and the notation f of x, they mean the same exact thing. All right, so we're going to play the is it a function game. And to play this game, you just need to remember each input has only one output. So in the example of the coffee, when 2 minutes had elapsed and I read the temperature off of the thermometer, I only had one value. It wasn't both 98 degrees Fahrenheit and 7 degrees Fahrenheit. It was a consistent temperature throughout the whole coffee, just one reading of the temperature. And that's the idea here. So I'm going to fill out some values here, and then we can decide if it's a function or not. So, and domains and ranges don't have to be numbers. Let me do this first example kind of crazy. Let's assign people to colors. So I'm going to give some people's name: Joe, Sue, Frank, Ted, Cindy. So we have 5 people, and I'm going to give you some different colors over here: purple, green, orange, red, yellow. Well, let's just do 4 colors. Let's do red. Okay, so Joe, his favorite color is green. So the function is favorite color. Sue's favorite color is purple. Frank's is also purple. Ted's is orange, and Cindy's is red. All right, is this a function? Well, you have to say, does each input have only one output? And in this case, yes, it does, right? Everybody has only one favorite color. Now, purple is more than one person's favorite color, but these are the outputs. And it's okay to have more than one input for an output. You just can't have more than one output for an input. All right, so then let me give you a different example over here. I'll do shapes: circle, triangle, square, oval, star. And these shapes are going to be sent to, let's just use numbers: 1, 2, 4, 7, 8. And then I'm going to put arrows to represent who goes to whom. Okay, and then I'm not going to answer this one. Instead, I want you to come up with the answer. Make sure you circle it really big and let me know tomorrow what you decided. Is this a function or not, this representation? All right, our third example here. So this was first example game, second in the game, and now the third one is I have a table of numbers, and I've listed the inputs and the outputs. Again, this is something I want you to do on your own. I'll go through these last 2 with you. Here we have analytic versions of functions. I have given you a function in an equation form. Y is the output and X is the input. And this first, or number 4 here, Y is the absolute value of X plus 6. So is there only one output for every input? And the answer there is yes. Another way of looking at this is you can look at the absolute value of X plus 6. It looks like this graph. So this is the graph. And this passes a vertical line test. So yes, this is a function. Okay, my next one here, number 5, is no. All right, and let me explain why this is a no. I'm going to go ahead and solve for y since it was not solved for yet. So I have y squared equals 1 minus 2x squared. And now to get y by itself, I have to take the square root of both sides. When you put a square root in, so I'm going to put this action in blue. Notice I put this square root in. I wrote this. It is not a part of the problem. It is a part of solving the problem. When you introduce a square root in order to solve the problem, you have to also put in a plus or minus. Okay, because what you're saying is what happens is there are 2 numbers who square to any one number except for 0. For example, 4. What 2 numbers square to 4? Written in math, what 2 numbers when squared are 4? Well, there are 2 of them, positive 2 and negative 2. And so mathematically, when you solve, what happened here is you took the square root of both sides. And so when you take the square root of both sides, then you write a plus or a minus because there are 2 solutions. That's different than the question y equals square root of x plus 1. Okay, that's given in the question. There's only one output here. It's the positive square root. So this is the question. When the question has a square root, don't put in a plus or a minus. But here, we don't have a square root in our question or in our given. We put that in. So we use a plus or minus. And that makes this not be a function. So the answer here is no, this is not a function. And that's because, for example, let x equal 0. If x equals 0, so this is one input, the input of 0, then y equals plus or minus square root of 1 minus 0. So y equals plus or minus 1. So that's two outputs, not a function. And there are lots and lots of inputs, infinitely many inputs that have two outputs. And then there's a shortcut here. Whenever the y is squared, that's not going to, because you have to do a plus or minus to solve for it, not going to be a function. Okay, now function notation. I already did a little bit of this. Y equals f of x is our typical thing. X is just a placeholder for inputs. So we don't always have to use the letter X. In this example, I used the letter S. And so remember, this is just a placeholder. This is telling me this is like a legend, and it tells me S equals the input letter. And so anytime you see the input letter of S, that's where you evaluate. That's what you plug into. So in G of 3, I will do 3 times. Now here's my input. I'm using 3 here since I'm putting that into the S. And so I get 9 minus 6, 3. Lots of 3's in this question. All right, what is G of X? Well, in place of S, I'm going to input this. So into the S, I'm going to input an X. So we get 3x squared minus 2x. And now the next input, it's asking me to input 2t plus 1. 2t plus 1 is going to go into every S I see. So I have 3. Now the next thing is S squared. So instead of S squared, I put 2t plus 1 minus 2 times S. And instead of S, I put 2t plus 1. And then you do need to simplify this. Okay, so that would be 3 times 4t squared plus 4t plus 1. I did that foiling in my head. Minus 4t, and I'm going to distribute my negative, minus 2. So this is 12t squared plus 12t plus 3 minus 4t minus 2. And that simplifies to 12t squared plus 8t plus 1. Okay, moving on. We're going to talk about domain and range here. There are 3 rules to find the domain. 3 rules. You right now only have to know 2, the number 1 and 2. This is a big rule. You may not divide by 0. You may not divide by 0. So in this question down here, you'll see that one of them, B, has a division symbol in it. And what we're going to do is set that denominator equal to 0 to see what we're not allowed to use. The next thing is to do the even root of a negative number. Okay, and we're going to do that one on C and D. And then the third one is a logarithm, and we're going to do more on this later. It is something that you have learned, but we'll review it when we review logarithms all at once. So those are the only 3 rules you have to know. In this first example, my very first question is y equals x squared. I need to know the domain and the range. Well, for the domain of this, I need to figure out if I break any rules. Could I divide by 0? No, because there's no division operation in this function. It is only squaring. Could I take the even root of a negative number? Again, no, because there is no square root in this function. I do not see any square root. The only operation they're having me do is to square. And then there's no logarithm. This means that the domain is all real numbers. So all real numbers. I shorten this to an R with 2 down symbols, and that's all real numbers. Okay, now let's talk about the range. Okay, what kind of outputs is it possible for me to get when I square the inputs? And that's something that you sort of just have to know. The range is actually a more difficult question than the domain sometimes. But another thing is I know the graph of x squared, and I know you know it as well. The range are the set of outputs or the set of y values. Notice that there is nothing down here where y is negative. Y is never negative in this graph. And so the range is that y is always greater than or equal to 0. And that's just because of the nature of what squaring does. I don't get an output that's negative ever. The only time I get 0 is if my input is 0. All right, so that's your answer for A. For B, we do have division. So I want you to see the division. And I want you to look at what you're dividing by. x squared plus 5x minus 12, and set that equal to 0. Now what we're doing is just playing devil's advocate here. In order to solve a quadratic equal to 0, you have to factor that. So we have x. I should add and subtract something. So I'm going to add 6 and subtract 1. Nope, that's not 12. How do I get 5 from 12? Not 3 and 4, not 6 and 2. All right, let me make this factor. Let me do, instead of, I'm rewriting this question. Let's go ahead and make that 12 a 6. All right. Okay, so if this is x squared plus 5x minus 6, this is the same as x minus 1 times x plus 6. That's how that would factor. And so x equals 1 and x equals negative 6, those would make the denominator 0 in this new question. So when the denominator is 0 is when x is 1 or x is negative 6. So for the domain, our domain is all real numbers except x is not allowed to be 1 and x is not allowed to be negative 6. That is the domain there. We are not going to do the range on this. The range turns out to be everything except 0. But it's kind of tricky to see that. The best way is just to graph it and see. So we'll do more on that later, perhaps. My biggest concern right now is domain. All right, on C here, y equals square root of x. Now we're in rule number 2. X has to be greater than or equal to 0. Whatever you take the square root of, you make that greater than or equal to 0. That's how this works. And then you solve that for x if needed. It's not needed here. So the domain is x is greater than or equal to 0. By the way, the range is also y is greater than or equal to 0. And you can do this if you remember what the graph of square root looks like. But it's also the rule that if I take the square roots are just always positive. They're always defined to be positive, except the square root of 0 is 0. All right, but on D, I'm going to follow my rule here. I see a square root. I know whatever I take the square root of has to be greater than or equal to 0. And so that's what I'm going to do to determine the domain. I take what's under the square root and I make it greater than or equal to 0. And then I solve for x. So if I add x to both sides here, then I get x is less than or equal to 4, and that's my domain. The range is the same. Y has to be greater than or equal to 0. That's all. That will be the range for all square roots. All right, the last one is a bit tricky because we have both a square root and a denominator. So to start off with, I'm going to use rule number 1. The square root of 1 minus x squared, the denominator, is not allowed to be 0. That means 1 minus x squared is not allowed to be 0. I squared both sides here. Then that means 1 is not allowed to be x squared, so that means x cannot equal plus or minus 1. Because in order to solve this, I had to do the square root of both sides. I put that square root in. If I put that square root in, then I use a plus or minus. So x is not allowed to be plus or minus 1. Okay, now let's do the other rule. The other rule says if you have a square root, then this has to be greater than or equal to 0. All right, later on in calculus, we're going to be very concerned when things are positive or negative. And the way that you do this is with a sign chart. And I know that you've done sign charts before, so this is going to remind us of how to do sign charts. This is not easy to solve. It is easy to solve if your thing under the square root or your thing in that red box there is like what was in the red box on the last one. It's linear, meaning that x has just the power of 1. So then you solve it simply because you just add and subtract or divide by constants. But here you can't do a square root with inequalities. It's illegal. You're not allowed to do it. It messes things up. It's not right. So instead, what you want to do is you want to keep this 0. Okay? Keep that 0. And you need to factor the other side. This is a difference of squares. So it factors as 1 minus x times 1 plus x. All right, so now that it's factored, that's better. We're going to start by setting this equal to 0, which we actually already did. We just did that over here. only I put a not through the equals. And so you get x equals 1 and x equals negative 1. That's going to tell you what numbers to check around. So I'm doing a sign chart here, but I'm not doing it the way you all did it last year. Instead, I'm just going to make it more succinct. I'm going to do it, I'm not going to make a whole table. I'm going to do it all at once. So what I'm going to do with this sign chart is I'm looking at this thing in green. This is where I am right now. I'm looking at my factored form of the inequality. And then I'm going to look at this number line here. And I'm going to test values. So my test values, which you don't have to write down, but I want you to see what I'm doing. You have to pick a number in each interval. See how the 1 and the negative 1 divide my number line up into 3 spots? The first spot would be from negative infinity to negative 1. And then the second spot is from negative 1 to 1. And the last spot is from 1 to infinity. All right, so in the spot from negative 1 to 1, I'm going to try negative 2. That's a number in that interval. I take the negative 2 and I plug it in up there. But here's the thing. I don't care what the value is. I only care about the sign. That's why it's called a sign chart. All I care about is the sign. So if I plug negative 2 in here, I get a negative, oh no, I get a positive because I get 1 minus negative 2 times a negative because 1 plus negative 2 is negative. So I just replaced the negative 2 in there, and I said this is positive. It'll be positive 3, but I don't care about the 3. I just care about the positive. And this will be negative 1. And again, I don't care that it's negative 1. I just care that it's negative. And then I will do a positive times a negative. And a positive times a negative is a negative. So overall, I get a negative. And that's what I write there, because none of that in-between stuff matters. All right, the next interval was negative 1 to 1. Here I'm going to test the value of 0. When I plug 0 in, I actually get 1 times 1. That's positive. But I get a positive times a positive. And then lastly, I'm going to plug in 2. So when I plug 2 in, I get a negative times a positive. And a negative times a positive is negative. Now, this is a chart that's going to tell me the answer. I want to know when 1 minus x squared is greater than or equal to 0. Things that are greater than or equal to 0, those are positive. And so the answer is where is the interval where I get positive values, which was negative 1 to 1. And so you write down negative 1 to 1. Don't include 1 or negative 1 because you're not allowed to, because that would make you divide by 0. So this was the hardest domain, but the domain is that x has to be between negative 1 and 1. All right. I believe, oh, we have one more thing. Difference quotient. Okay, so the difference quotient is a little bit tricky, but it is an important concept in calculus. This is the difference quotient right here. And I'm going to change this problem to 3 plus delta x minus f of 3 divided by delta x. Okay. And this is the only example I have. But notice f of x here is x squared minus 2. And what I want you to find is I want you to find whatever this is. This is the difference quotient. So my difference quotient, but it's my difference quotient when x equals 3. At x equals 3. And so I'm just going to literally write that over again. F of 3 plus delta x minus f of 3 divided by delta x. Delta x is part of the difference quotient. It's going to be in the answer also. The only thing you need to simplify here are two things, f of 3 plus delta x and f of 3. And to get those two things in those red boxes, you look at your original function. I'll find f of 3. It's very easy. F of 3 is 9 minus 2. It is 7. So I'm going to put the 7 that I got there into this red box. 7. That goes there. Now let's find f of 3 plus delta x. That's the other red box. F of 3 plus delta x. Okay, so I replace the x with 3 plus delta x. That needs to get squared and then minus 2. All right, that's got to simplify. So let me, sorry, all over the place here. I'm going to simplify that over here. So when I have 3 plus delta x squared, that means 3 plus delta x times 3 plus delta x, and then minus 2. Got to multiply first. This is a FOILing, so I'll get 9 for the first. The outside gives me 3 delta x. The inside gives me 3 delta x. And then the last gives me delta x squared. And then I have a minus 2 at the back. So then I can simplify this, collect like terms. 9 minus 2 is 7. 3 delta x and 3 delta x, those are the same. That's 6 delta x. And then delta x squared. All right, so that is my simplified version of what was in this box here. And so what I've done in red is side work. Red, side work. Okay, so now that I have those things figured out, I'm going to go back to what I'm supposed to find. It's f of 3 plus delta x minus f of 3 over delta x. Okay, so I didn't do anything down there. That's still delta x. But the first red box, f of 3 plus delta x, that's this, right? So that I'm going to put in that spot 7 plus 6 delta x plus delta x squared. And then I'm going to subtract f of 3. That was a number. I did that earlier. That was 7. Now this is going to simplify, and if you did your side work correctly, it will simplify every time. See the 7s? They canceled. So I have 6 delta x plus delta x squared over delta x. Interesting. There's a lot of delta x's there. That delta x is a common factor. It will factor out. Then in the numerator, I have 6 plus delta x left. And notice now these will cancel. By the way, don't cancel. Don't get cancel happy on me. You can only cancel whenever you have factored first. Factor first, cancel next. So if you want to try to cancel things, make sure that you have factored first. Now my final answer is 6 plus delta x. Okay, and that's something that you will work on in calculus, but everything I've done so far to evaluate this difference quotient has just been pre-calculus. It's just doing a lot of side work and then simplifying. Later on, I'll explain what that means in calculus. All right, we're done.